Hey everybody, welcome back to episode 68 of the video series in which we program an entire video game from scratch, from beginning to end, in the C programming language. I believe last time we worked on asset loading code, if I remember correctly. Yep, that's correct. Today, well, we're going to do a couple things, but first, before we do anything, I want to show you the new and improved splash screen that I've come up with. Let me just show that to you. There it is in all its glory. Let me just run that by you one more time, just in case you missed it. Okay. I decided to do that off camera because we've already covered everything that was required to do those sorts of things. So it came to me last night in my sleep, quite literally, a long, long time ago, way back when I was in high school. I built a Tesla coil that, a device that, took up half the garage and shoots lightning. Did all of that by hand. We had to wind the copper wire around the giant piece of PVC on a big aircraft lathe and everything. It was really cool project. Anyway, so the phrase pole pig, if you're not familiar with what that is from, it's a slang term for a distribution transformer. Like here, I'll show you. Uh, there we go. It's this is what a pole pig is, right? It's a distribution transformer. And so, I actually, we made a bunch of phone calls and called around and actually was able to purchase one of these things for our own personal use, and incredibly dangerous, but we did it anyway. Um, so anyway, that's what a pole pig is, and I decided that I would go ahead and I just went into paint.net to draw this thing. This is the basic schematic of a Tesla coil, except the top load, which is usually some sort of like toroid shape. I replaced it with a pig, and then I made a little lightning bolt, which is like right here. I just drew these things in paint.net, right? And then I imported them in the same way that we import everything else, like in main.c. Had to create a new variable for these things. I created here you go, global pole pig logo and global lightning 01. And then somewhere in the asset loading thread, I went and added these things to the list of essential assets. And by the way, I think I fixed this up a little bit since last time too. I actually made two separate arrays, right? Like this array of assets is the quote unquote essential assets, and this array, this larger array, is the everything else assets, right? So then we go and we load all of our essential assets, and once we've finished loading our essential assets, then we set the event that tells our main thread that the essential assets are loaded and that it may proceed to draw the splash screen. So, and then I just went into the opening splash screen.c and, basically went in here into this logic and, I basically just, like the lightning flashes, I timed it to go roughly along with the sound effect. And the new sound effect, of course, I just created that in BFXR or BFX or whatever you want to call it. I just, essentially just generated a bunch of random noises, as you can see here, until I found one or two that sounded somewhat like, electrical discharge, I guess, or lightning. And then I used the mixer to sort of play them in a, sequence so it sounds cool. And then I exported that, imported it into the game, and there you have it. There's my splash screen. And there's the story behind why My game studio name is what it is. Um, we could talk more about Tesla coils later if you want to. But anyway, that's not what we're here to do today. What we are here to do today is, what do we want to do today? Actually, I know what we should do today. I'm looking at the repository on GitHub and I noticed a couple of issues. I kind of want to take care of both of these issues. The first issue comes to us from, again, Corey, who coincidentally is someone that I have known since high school. We were both really into computers way back then, too. This was well over 20 years ago. We still know each other, and he actually sent this issue. He's following along with this code, and his complaint, he lodged an issue here. He raised this issue that says when you press F1, which if you don't recall, I'll just start this. If you hit F1, it brings up this debug text, right? This debug HUD, if you want to call it that. And you hit F1 to toggle it on and off. And his complaint is that, well, F1 on his system also is the operating system shortcut for bringing up the help, which I'm not sure why mine doesn't do that. Like if I'm in Microsoft Edge and I hit F1, then it brings up Edge help. But if I'm in the game and I hit F1, no one else intercepts it. Like I don't have that problem with the operating system intercepting my F1 key presses. But so his suggestion is maybe we need to handle the WM key down message, and so we can somehow like intercept F1 so that it won't be passed to the operating system, and so it won't open up the help on his operating system. But I thought about it for a long time, and I don't think that is the route that we. I don't think that's the route we want to go down. Like it's actually and I'm sort of biased because I do work for Microsoft and Windows support, and so these I see a lot of issues along these lines. People trying to basically circumnavigate built-in Windows hotkeys and stuff, and essentially I don't want to start playing the game where we try to fight the operating system uh, for whose hotkey is going to take precedence over whom, and that sort of thing. So I think I would like to handle this a little bit differently, and what I would like to propose, my counter proposal, is going to be that we simply allow it to be configured. We are going to allow the user to configure which key they want to use to toggle the debug heads-up display. So if you don't like F1, or if F1 isn't working for you for some reason, then you can just move it to F2. So how are we going to implement that? I say we implement that in, let's go over to main.c, let's go to load registry parameters. Okay, so load registry parameters is also a function that we have not really touched in a long time, and coming off of the heels of the last episode where we gave our asset loading function a once over, um, and we went back over it and we improved it quite a bit. I say that this function right here probably would benefit from the exact same treatment as our asset loading function from last episode. And by that I mean if we should probably define a new data structure in here to represent all of the various registry settings that we are going to look for. And this data structure will have the name of the registry setting, the variable in which it will be stored, the default value if the registry setting is not found, probably a min and max value, um, a min and max value, to check to make sure that it's that the setting is within the correct bounds, that sort of thing. And I think by doing that, we will probably improve this code. We'll make this function smaller for sure, right? Um, that being said, before we do that, I don't want to do two things at once. I don't want to try to add to the function and also improve the function at the same time. I just want to do one thing at a time. So first, let's just go and add the new key that we want to add, right? So to do that, I'm just going to copy this last thing here for music volume, paste that in there. Okay, and we're going to call this this registry setting, we're going to call it um, debug, debug, debug key. And it's going to be a D word, and it's going to have flags of null, or yeah, null. Hold on, flags are oh, okay, I forgot what PBW type. This is only necessary if you need this will output like the type of the registry setting. Like it'll tell you if it was a string or a D word or what. But we're not really using it. We're using this parameter to basically say, this setting has to be a D word in the registry. This registry setting has to be a D word, or else the function will fail. And then we're storing it into this variable, which I forget if we had. Do we even have a global for debug? Mm, let me go to and this. Let me go to another function. Uh, create main game window. Drop. Process player input. Okay, and then that reminds me. I'm going to write myself a note to do. Rename this to collect player input. And the reason I say that is because I feel like this function process player input should actually be called collect player input because that's all we're doing in this function is we're collecting player input. And then when we go down to here, when we dispatch to these various PPI underscore opening splash screen, process player input underscore gamepad unplugged, process player input underscore title screen, etc. That's where we're actually processing the player input. We're actually making changes to the state of the game based on that input. But here in this function, we're simply collecting player input. That's my thinking. So I think we should eventually rename this function, but we won't do it right now. What we are going to do right now is we're going to change this where it says our ggame input.debug key is down is virtual key F1. And I want to change that. I want to change that to G debug key, right? And of course that doesn't exist. So let me go back to main.h. I'm going to make sure, I need to scan real quick and make sure that we haven't already made a pound define for it because I honestly can't recall and I don't see it. Don't see it. Okay. And make sure it's not in game input. Well, obviously, disregard that. Game sound, game area, perf. map. Yep. Let's go down to the global variable declarations. Make sure it's not in here. Game input. All right, it's not. We don't already have this. So now I'm going to go back to main.c because I don't think this needs to be an extern variable because I don't think we're going to be accessing it from any other compilation unit other than main.c. So let me just all right, so I said begin initialization of external globals here, but I don't know. That appears to be all of them. There's no end, is there? That's not cool. Okay, so we're going to say this is a int32, I guess. G debug key equals VKF1. Right. Right. Okay, back down to process player input. This is fine. Now we need to go back to our registry parameters, load registry parameters, go back down to the bottom. Right. Okay, here we go. Debug key, and we're going to save that value in G debug key. And if that was not successful, then if the result is file not found, then we're going to go with the default, because if you haven't set it, debug key using default value of VKF1, and this is not necessary to set this because it's already been set, but we're going to reset it there anyway. And then if the reg get value failed for some other reason other than the registry setting was just not found, then it's an actual problem and we should report it and exit. And then finally, we are just going to report it like so. We're going to get rid of that. Debug key is G debug key. Don't need that. Okay, so I think that's done. And let's test it and see. Of course, that still works. F1, F1, F1. Okay. Now, let's say F1 doesn't suit our purposes and we want to change it to something else. Well, in that case, we just do registry editor. We're going to open the registry editor. We're going to do software. Let's see. Yeah, current user, software. What is this game called? Game B. Okay, and you can see I've got a few things in here already. And I'm going to add a D word, and I'm going to call it debug key. And I'm going to set it to hexadecimal 71, which is decimal 113. And just to double check that I have that correct, we'll go to Google, virtual key codes, search for VKF1 is 0x70, VKF2 is 0x71 is F2. And there I've set it to 0x71 hex. All right, so let's run it and see what happens. Now, if I hit F1, nothing happens. If I hit F2, now it toggles my debug my debug HUD. Okay, so that was easy. And with that, we're going to go back to GitHub, and we're going to say resolved this issue by adding a gdebug key global variable and a debug key registry setting under hkey current user game B, which you can configure to any virtual key you like. For example, 0x70 equals VKF1, 0x71 equals VKF2, and so on. So if you set the debug key registry setting to 0x72, the debug HUD will toggle with the F2 key. Close. Okay, issue closed, and let's see, what is this? Issue number 12 is what it was. So let me go back here, back to get changes, resolve issue number 12 by allowing user to configure debug key in registry. Commit and push. It's thinking. It's pushing. Maybe. I don't know why this is taking so long. Failed to push. Let's try it again. Oh, that time it succeeded. So I just had to do it twice for some reason. Now if I go look at main.c, resolved issue number 12, which is kind of cool for GitHub, to automatically link this git commit message to the issue number here. It's kind of cool. It's pretty sweet. Very cool. All right, everyone loves GitHub. Now, the second thing we want to do is pretty interesting. Issue number 9, alpha blending. So this guy, or sorry, this person, I don't know if it's a guy, it's just a person. They say, hey Ryan, I've been following your tutorials for a while and I saw that you haven't covered alpha blending yet. And that is true. I have not covered alpha blending yet. And honestly, when I first set out to make this game, I didn't ever really plan to address alpha blending at all. And the reason why is because the original, when I first conceived of this project, it was to make an old school NES, that's Nintendo Entertainment System, like 1985 classic NES style video game, circa 1985, and the classic NES did not support alpha blending. There was no alpha blending on that console. So I thought, I probably will never do alpha blending either. That being said, we are leaving a lot on the table by not using alpha blending because recall, we are using 32-bit per pixel graphics everywhere. So all of our graphics are BGRA. We have this alpha channel that we're not using, we're not doing anything with. So, we're leaving, a pretty important feature on the table. Secondly, alpha blending is such a fundamental thing. It's such an important thing that you're probably going to want to do. So, even though I didn't plan on doing alpha blending originally, I should cover it. This person is right. I should cover it because it's such an essential thing for most people to want to be able to do. It's just a very basic uh, feature of doing graphics these days. So I will say that while this person's I apologize, this person's function, this algorithm looks, it definitely looks viable and it probably will work. However, I see here that we are shifting to the right 8 bits on each color channel, and I will show you why you may or may not want to uh, do it exactly like that. So this is a pretty big leap for us here. We might have to make some pretty hefty changes in our code to really support this. So without further ado, let me start off by saying this function right here, blit 32-bit per pixel bitmap to buffer. Obviously I think this is the hottest function in our entire code base. It's called every frame. Obviously, it's called several times per frame. You recall the draw text function that we wrote is also a wrapper around blit 32-bit per pixel bitmap to buffer. So this type of function, this function is called several times per frame, 60 frames per second, so hundreds of times per second. This is called. So the reason I bring that up is because you have to keep in mind to do whatever is in your power to keep this function as high performance as possible. You really, if you don't want to drag the performance down in this function especially, right? So like if any function in our entire code base is going to be fast, it should be this one. This needs to be the best performing function in our project. All right, so I'm stalling. Obviously, you can tell because I keep talking. And what needs to happen is, what I feel needs to happen is we need to enhance this function to contain a bitmap flags the same way that we had the same way that we did to say our draw window function. This is our draw window function, and then in our draw window function we allow the user to supply some flags, and these flags define, they change the behavior of the draw window function. You can matter of fact, let me go over to main.h, and I think it's up here in the enums. Here it is. Window flags enum, right? So you can have a bordered a bordered window or rectangle. You can have an opaque rectangle. You can center it horizontally, vertically, give it a shadow. There's a shake effect that we've never implemented. Rounded corners, thick borders, etc. The thick borders is especially cool because it implements recursion within the draw window function, which I thought was a really neat trick. But we need to do the same sort of thing with the blit 32 bits per pixel function. And this is going to be painful because We use that function all throughout our code, and so it's going to require changes to basically every single source file in the project. If we change the blit32 BPP bitmap to buffer function, and this is why, you know, APIs don't change very often. Like the Windows API doesn't change very often because we can't, you know, go and just break the entire world just because we, you know, wanted to add a new parameter, add a new argument, right? So what I may do, I think that's what I'll do. I may actually I'm going to take a page out of the Windows API book for this, and let's go back to the function. I'm probably going to go and create a new function, and I'm going to call it something like blit32 bpp bitmap to buffer ex. Okay, and then, you know, we can add all new arguments to it, allow it to support new flags and stuff that the old one couldn't support, and that way we can migrate people over to this newer copy of the function at our own pace, right? We don't have to go and break our entire project because we decided we wanted to change this function and add something to it, right? Right, so let's do that. All right, so this part's going to be the same. It's going to take in a bitmap. It's going to take in a X and Y. And here is another thing while I'm on this, I made this a 16-bit. I made the X and the Y here 16-bit, 16-bit integers. And the reason why I did that is because, well, our resolution, our game's resolution is 384 by 240. It's a, you know, very, very small screen, right? However, it's too big for an int8, right? We couldn't have it be an int8 because 384 is bigger than 255. It wouldn't fit in an int8. It wouldn't fit in a uint8 either. So we can't do that. But so I figured, well, 16 bits is definitely big enough to place a bitmap anywhere I want within the coordinate system, within the resolution of 384 by 240. And that's fine. That works fine. But, you know, the more I think about this, the more I think there really was no point in me restricting this to 16 bits. What I mean by that is, if I just made this int, now those are 32-bit integers instead of 16-bit integers. I don't think that I'm really saving myself. I don't think I'm getting myself any sort of memory efficiency or performance, either one, by making those 16 bits. You think, you know, I don't know about you, but I mean, I am inclined to think, well, if your variables are smaller, then you could probably pack more of them into like the CPU cache or into, you know, the same space in memory, etc. But in reality, I don't think it quite works that way, especially in a situation like this. So what I'm trying to tell you is that, you know, I don't think this is I don't think that I gain anything by explicitly making those 16-bit as opposed to just allowing them to be regular 32-bit ints. That being said, we could use, in order just you know, stay consistent with the standard int.h library, we could do like, what is it, fast int fast8. So we'll do int fast16, And same thing with this guy over here. And okay, so question is, what is that? And before I try to explain it, let me just look up the documentation. Int underscore fast 16 is the most efficient type in speed with at least the range of a 16-bit int. So all right, so example, in a 64-bit machine where one would expect to have int as 64-bit, which it's not on my platform, int is 32 bits on my platform. Compiler may use a mode with 32-bit int compilation for compatibility. In this mode, could be, okay, so in this mode, an int a fast 16 could be 64 bits, as that is natively the fastest width for it, and it avoids alignment issues and stuff like this. So basically, by using this data type, a fast 16, we're saying that I want at least 16 bits. You guarantee that you're giving me at least 16 bits here, so I can store numbers that all the way up to 32,000, around there, 32,000 something. However, if it is more efficient to use a larger data type, then go ahead and use the larger data type. So once I uh, disassemble this and look, this may actually end up being a 32-bit int. Oh, well, and you can look and see, like, it's already defined for me. It's going to just use an int, which is 32 bits, because on this platform, ints are faster, at least in this context, right? So I feel like that hopefully I explained that well enough, and um, this is kind of like the best of both worlds. Is kind of a win-win because we're not sacrificing. We know we're not sacrificing any sort of performance because we're using fast this data type, which is just statically type def to an int on my platform. If I switch to some other platform like Mac OS or Unix or something, that this may be different. But here on this platform, it's telling me right away that look, int is more efficient than literally a short, which is a 16-bit integer. So, and then secondly, we're staying with the same theme because the standard int header file, we are using that everywhere, and I really like it, and I think it makes our intent clearer when you're reading the code. So let's just stay with that. Okay, so back on track. I'm liking this so far. Now, what we need to do here is we have this third argument or fourth argument called brightness adjustment down here. Now, I'm thinking to myself that if we're going to do alpha blending, well, there's two things I don't like about the brightness adjustment parameter. It does not give us any control over the individual color channels. Like, what if I wanted to only adjust the redness of a bitmap, right? What if I only wanted to adjust the greenness and make a bitmap more or less green or have more or less blue in it? This right here doesn't allow that. I could make it a mask if I wanted to, or I could just make it three separate parameters. The other problem with it is once we implement alpha blending, like true alpha blending, well, then that sort of makes this brightness adjustment parameter obsolete, right? Because they'll just be a new argument called alpha adjustment or something, and it will just adjust the alpha channel, and we'll use that in our alpha blending calculations. So that'll allow us to like fade in and fade out our bitmaps. And yeah, so let's go ahead and do that. What we're going to do now is, I guess we're going to let's see. Yeah. All right, let's just keep going. Int fast16 blue adjust. And if you don't want to adjust the colors, you just let these be 0, right? And int fast16 green adjust. Int fast16 red adjust. And finally, we have int fast16 alpha adjust. And now we need flags. There. Question is what flags? Like when I first thought flag, I originally thought, well, maybe we'd make a flag called, um, blit flag alpha blend, right? And if you are missing, if you don't have that flag, then we just won't do the alpha blending algorithm at all. I'm thinking we probably need a flag for like, what if you want to replace a particular color with transparency, right? So if you wanted to, let's get past all this MD stuff. Yeah, we already do that, right? See, we just here in this really old code here, we adjust red, green, and blue, all of them by brightness adjustment. So there's just one adjustment for every color. It doesn't allow us to play with the color levels individually. So I'm thinking that we're probably going to want some other flag for like, what if we want, to supply a color to this function and say, I want this color to be transparent. And, that'll be really easy to do, but we don't have to do it right now. What we do need to do right now is say to do what flags do we need here, right? Okay, so now I think I can go ahead and copy this code out of my old function because it's going to start off the same way. That is, we take starting screen pixel. And on these, you think, well, wait, should I use the fast? Should I use the fast ints here? And I have to be really careful doing that. Right now, it doesn't matter because we know that a fast int32, it is an int, right? Like if I just type int fast32, it is an int, so there's no difference. So there's absolutely no difference. So I'm not going to change that right now. I'm going to leave it as is. And then secondly, remember we did all the AVX2 stuff and the SIMD stuff. Don't have time to do that today. What are we looking like for time? We're already at 45 minutes, so I don't want to do alpha blending and the SIMD implementation of alpha blending at the same time. So for now, let's just do the slow, like pixel by pixel version of alpha blending. So I'm going down here to this chunk here that is if def out, right? I'm going to copy that, and we will, we can SIMD it later, but for now we're just going with this. We're going to go ahead and do this. We're going to do type def enum blit flags, I guess. We may come up with a better name for that later. I don't know. Blit flags. And our flag is going to be blit flag alpha blend equals 1. Okay, and that is our only flag for right now. We may come up with other flags later. That's the beauty. That's the whole beauty behind using flags like this is we can implement an infinite number of flags as we go, as we think of them. But for right now, we only have one flag, and it is alpha blending. So I'm going to go down to here. This needs to go because we no longer are going, this is not going to be relevant to us anymore because we're going to be blending all sorts of different colors. Oh, and by the way, I don't know if I ever explained what alpha blending is. I'm so sorry. I'm a terrible teacher. Let me do that now. Let me go back to paint.net and create a new image here. Just just in case you guys are not familiar with what alpha blending is, I'll show you to you real quick. Alpha blending is this. I'm going to, let's see, paintbrush, brush width is going to be 16. We're going to find a red color, red. Okay. Now our game currently, it only has the ability to just do like the pixel is either completely on or completely off, right? There's no anti-aliasing, there's no blending, there's no opacity, there's no like variable levels of opacity, if that makes sense. So if I take another color, like let's say blue, and I paint over the top of this, well, the blue stripe, it just paints over the top of the red stripe, right? So that the two are not blended together or anything like that. It just goes over the top of the red. There's no blending. But what if I have this? I have this blue color here. What if I take the alpha channel, which is opacity? See how it's currently set to 255. What if I set that to 127, halfway, and I'll draw another stripe? You can see that it's. So you can see up here it's really light because it's blended with the background color. So blue blended with white, you get this lighter shade of blue. When I hit this red stripe, you get the blue, and because it's half opaque, it's blended with the red color underneath it, and it gives you a purple, right? Because blue and red make purple, and it's that simple, right? So green. So here I have a green. If I make this half opaque, blue and green make yellow, right? Is that how that works? No, apparently that's not how it works. But anyway, you can see that the colors are blended together, right? Blue and yellow, or is it blue and yellow make green? That's what it is. Blue, or is this yellow? Yeah, yellow, 127. Yeah, so blue and yellow, I guess this is some sort of green. Is it? Not really. It's just some sort of muddy color. But anyway, that's what alpha blending is. So the idea is we're, instead of just, painting the pixel over the top of whatever used to be there, it may be black, it may be another bitmap, who knows. Now we're going to blend it with whatever the colored pixel behind that is, right? Pixel by pixel. So this right here, let's comment this out real quick for now. We'll bring it back later. So here if you don't remember, this is code that we wrote a long time ago. But in these nested for loops, these nested for loops give us this pixel by pixel effect, right? So we're drawing a bitmap pixel by pixel from the bottom left all the way to the top right. And we do that by calculating these offsets, and then we copy uh, we copy whatever is in whatever bitmap that we have requested that to draw, plus whatever offset, whatever pixel we happen to be on. We load that into bitmap pixel, and then what we used to do is we say, well, if the alpha channel is turned all the way on, then we are going to, make our red adjustments, and then we're going to copy that pixel onto our background, into our background buffer. Of course, what this code basically means is that we'll never be able to implement like like anti-aliasing, or obviously not alpha blending. But tonight that changes. So we have to make one extra step though. If we're going to alpha blend, we need one extra piece of information. We need the background pixel, right? We need to know the background pixel because we need to know what color we need to blend with. So we're going to have to add another memcopy here because we need to pick up the background pixel first before we do any blending. So we're going to have to create a new variable. And I guess it goes up here. Make a new pixel called background pixel. Okay, so let me go ahead and make some comments here. Calculate the offset into the back buffer where this pixel will be drawn. Bitmap offset is calculate the offset into the bitmap image that we are drawing, to the back buffer. Trying to make this make sense to myself and to future viewers and readers of this code. Okay, so load the pixel from the load the single pixel from the bitmap image. Okay, and then say if flags and blit flag alpha blend, was it? Okay, so if we are alpha blending, then we're going to make an extra mem copy here, and we are going to background pixel, size of pixel 32, G back buffer memory. Sorry, this needs to be there we go, plus memory offset, right? And of course, this needs to be 4 bytes as well. Okay, if we are alpha blending, pick up the background pixel first so we know what we are blending with. So when we know what color we are blending with. Okay. And I think we need yet another pixel here. I called blended pixel to store the result of our alpha blending calculation. Now we just need to blend each color. So we're going to do this in BGRA order. Blended pixel dot colors dot blue is going to be bitmap pixel blue, sorry, colors dot blue times bitmap pixel dot colors dot alpha, and I'm going to do 2 divided by 255 here, and I'm going to do add background pixel dot blue times 255 minus bitmap pixel dot alpha. And we're not quite done yet. We need to, let's see, 255 alpha. We need to divide that by 255 as well. Let's see, am I missing? I think that's correct. And of course, you know, you can go online, and I didn't invent alpha blending. I didn't invent this algorithm. You can go and find it yourself, alpha blending algorithm. You can look this up on Wikipedia or whatever. You know, you could do this math yourself. The difference, remember back in the GitHub issue here, this person here is shifting right by 8 bits, shifting to the right by 8 bits instead of dividing by 255. And that is actually faster. Shifting to the right 8 bits is faster, but it's also not as accurate. It's the reason why it's faster is because the compiler knows that shifting to the right by 8 bits is equivalent to dividing by 256. Okay, but dividing by 256 is not the same as dividing by 255. So your colors are going to be very slightly off. You may not even notice, but then again, if you're going for like perfection in terms of like color accuracy, I think you should go with the divide by 255 method, even though division is a slower operation than bit shifting. This also is more accurate. So shifting right by 8 bits is faster, but dividing by 255 is more color accurate. That's my opinion. But that we've only done the blue channel, so we need to do the rest of the channel. Blended pixel colors dot green equals bitmap pixel colors dot green plus, or sorry, times bitmap pixel colors.alpha over 255 plus background pixel colors dot green times 255 minus bitmap pixel dot colors dot alpha over 255. Okay. Let's do red now. Blended pixel colors red equals bitmap pixel colors red times pixel colors alpha over 255 plus background colors red times 5 minus bitmap pixel colors alpha over 255. And this, this formula, if it may actually be able to be simplified in another way besides just the shifting by right, shifting right bitwise 8 bits. But for now, okay, this is now our blended pixel now contains the color that is the alpha blended result of our foreground pixel blended with our background pixel, taking into account the intensity of the alpha channel. So if your alpha channel is 255, that means your foreground pixel is opaque and no blending will take place. If your alpha pixel is 0, that means it's transparent and the background pixel will shine through completely. And if it's somewhere in between, it'll get blended to some varying degree. Okay. Now all we have to do is one more mem copy to lay that pixel down into its final resting place. Pixel 32, G background buffer, sorry, G back buffer memory plus offset. And of course the source is going to be our blended pixel. Sorry, I'm messing this up, aren't I? Size of 32. Blended pixel, size of pixel 32. That should do. Okay, and then of course, if there is no alpha blending taking place, then we can fall back on our old method of how we used to do it, which is this right here. Right? So if we're not alpha blending, then here you go, which we've already covered this. We need to implement, we probably, what do we need to do? Blue adjust, green adjust, red adjust. Okay. Red adjust. Green adjust. And this is blue adjust. We are going, this color adjusting is going to, we want to support color adjustments regardless of whether we're doing alpha blending or not, right? So I'm going to move this out of here and put it up here so that There. That way we do the adjusting, the color adjusting, regardless of whether we're alpha blending or not. Then if we are alpha blending, we do our alpha blending stuff. And then if we're not alpha blending, then we're simply going to drop the pixel into the back buffer if the alpha channel is 255, aka fully opaque. So I think this is done at this point. So now what is left is to test it. How are we going to test it? We kind of need bitmaps, don't we? Let's see. Yeah, we are over time, but I think we're almost done. I'm going to say new. We're going to make this 32 by 32. I'm going to make it transparent background. I'm going to do a rectangle. Brush width is going to be 8. And it's going to be blue. Okay, that's a little too thick. Okay. And we're going to save that as in our assets folder as a 32-bit bitmap image, BMPX, and we're going to call it blue square. Save. Now we're going to create a new one. This is going to be 32 by 32 also. We're going to give it a transparent background. I'm going to draw another shape. It's going to be a circle. And this one is going to be red. There we go. Save as BMPX. That's a 32-bit per pixel bitmap, and we're going to call it red circle. Save. Close. Okay. Back to main.h now. And we're going to say, we're going to go back to our variables and make these real quick. And that's, I hate to do it because it's just temporary, but I need to show you how this works. So we're going to go here. Turn game bitmap G blue square and G red circle. Okay, copy that, go to main.c, back up to the top. Here we go. Have to initialize them. Okay, and then we need to go to asset loading. Blue square.bmpx. Store that in G blue square. And red circle. Red circle.bmpx. G stored in G red circle. Okay, I think that's it. Build, rebuild. Everything's working, I believe. We'll fix all that stuff later. I need to go here. I need to build a new assets file because I added new assets, right? Okay, edit. Okay. Blue square, red circle. Save. Now we will run this batch file. We will double check the log just to make sure that everything was successful, and it was. Okay. Now we'll go to wherever we want. Let's say title screen, title screen, title screen.c, draw title screen. Somewhere in here, we'll just stick it right here. To do testing, remove this later, obviously. Okay, blit 32. Oh, you know what we never did? We need to go back to main.c. We need to go back to blit 32 bpb bitmap to buffer ex. We need to copy this. Then we go to main.h. We go back all the way down here to our function declarations, and we stick it in right here. Didn't need to type void there. There. That should do. Now, back to where we were. Title screen, blit 32. Blit 32. Okay. The bitmap is going to be G red circle. The X coordinate will be 8. The Y coordinate will be 8. Brightness adjustment will be 0. And then I'm going to do blit. This is the old version, remember. The old version of our function that does not support alpha blending. Blue square. And it will be 10, 10. So the red circle and the blue square are obviously going to be overlapping, right? So let's see what they look like. Okay, there in the upper left-hand corner of our screen, you see that we draw a red circle, and then because we're still using the old version of our function, the blue square just goes flat on top of it. You also see we lost the anti-aliasing on our circle. You can tell we lost the anti-aliasing. And what do I mean by that? Let's go back and look at it. Do I still have paint.net open? Open. Red circle. Zoom all the way in. There, if we zoom into red circle, you can see that there is anti-aliasing on the circle. And by that, I mean some of these pixels are not fully opaque. And the obvious reason for that is so that the circle looks smoother and the graphics look nicer. Even though the original NES was not capable of doing this, there was no alpha blending on the original NES, you probably will want to do it or want to know how to do it. So that's what today is all about. You can see that we lost our anti-aliasing. We also have no alpha blending capabilities whatsoever. So we just get our blue square just plopped right on top of our red circle. No blending takes place at all. So let's do something about that now. Let's change these functions to our new and improved EX version. Okay, so same coordinates, but this time it's going to be, let's see, blue adjust, green adjust, red adjust, alpha adjust. So no color adjustments, and let's, just for the sake to make sure that the function works, let's also omit the alpha blending flag for now too, right? Uh, 0. Okay. So this basically, I think, should produce an exact same result as what we just saw last time, unaltered from what we just saw. So we'll double check that and make sure. It does. It's the exact same. Now, here is the the climax of everything that we've been working on tonight. Blit flag alpha blend and blit flag alpha blend. Run it one more time. Splash screen. And then finally, oh, we didn't change the opacity, but this is already a good sign, because as you can see now, if you look closely at our red circle, you can see that our anti-aliasing is back, which means you already know our alpha blending algorithm is working, because those anti-alias pixels that are not fully opaque, those are getting blended with the background black color. So now, one last thing is we are just going to let's adjust the alpha channel on our blue square. Does that work? Let me think. Does it work? Let me go back and double check, because I don't think we ever implemented that, adjusting the alpha. So let me go back to main.c. We did not. Bitmap pixel colors alpha equals, and we have to clamp this between 0 and 255, obviously. Bitmap pixel colors alpha, plus alpha adjust, and clamp that between 255 and 0, and that needs an extra parenthesis. Now I think we're good to go. Let's run it and see what happens. Watch my beautiful splash screen one last time. There you have it. Our blue square, the alpha adjust, since it's now been, we made it half opaque. So you can see the blue square is now like, it's like a ghost image, right? Overlaid on top of the red circle. And you can see where the blue square intersects with the red circle, the pixels are like a purple color, right? Because it's the red blended with the blue, it's making a purple color. And so success. Yes. Perfect. All right, guys, that is it for tonight. This was a good episode, an important episode, and we can finish off the night by closing this issue, because now we do officially have an alpha blending episode. We have a very good working alpha blending algorithm, and if you want, you can go and try this. Try using the shift right bitwise by 8 bits instead of dividing by 255. And I think if you pay really close attention to the colors that are produced, you will find that this algorithm is faster. The shifting right by 8 bits algorithm is faster. However, it's not as precise in terms of fidelity to the colors. Like, your colors will be just like ever so slightly one tiny shade off, almost imperceptible. So if you're working on something that needs to be really fast, then you know how to do it now. This algorithm is faster. But if you need something that is more faithful to what the colors should be, then use the divide by 255 method too. And also, you might want to double check me on this. I'm not a mathematician, so I'm not 100% sure if this algorithm could not be further simplified. I kind of feel that I kind of feel like I could simplify it further. Um, I'll keep thinking about that. Anyway, that's enough for tonight. Um, if you have any questions or comments, please leave your questions and comments in the comments section on the video. Um, you can also find me on Twitter, also, etc. Follow me, engage with me there. I will happily answer any questions, any interesting questions or comments that you may have. Also, don't forget that there is a obviously companion GitHub repository that you can go and follow along with all of this code that I've been writing for all this time. And that is it, guys. Thank you very much for watching, and until next time, goodbye.